Welcome to Cosmic Compass, where we explore the mysteries of the universe together. From distant stars to the planets in our own backyard, every story brings us closer to understanding our place in the cosmos. Today, let's turn our attention to one of the most surprising discoveries of recent years, the detection of phosphine gas in the atmosphere of Venus. On Earth, phosphine is strongly associated with life, so when astronomers spotted it on our nearest planetary neighbour, it sparked an extraordinary question. Could Venus, the planet we thought was dead and hostile, actually harbour signs of life? This isn't just another science headline. It's a story that challenges what we know about biology, chemistry, and the uniqueness of Earth itself. So let's dive in and trace the journey from discovery to debate and imagine what it would mean if we're no longer alone. What if the first sign of life beyond Earth wasn't found on some distant exoplanet, but right next door on Venus, a world we usually imagine as hell itself? At first glance, Venus seems like the last place to expect life. Crushing pressure, extreme heat, and clouds filled with sulfuric acid. And yet, a strange discovery has challenged that assumption. Astronomers detected a molecule called phosphine in its atmosphere. On Earth, phosphine is strongly linked to life. In this story, we'll explore what phosphine is, why its presence on Venus is so puzzling, and how scientists are carefully testing whether this might be the first evidence of extraterrestrial biology. Let's walk through the journey step by step. After the initial detection, scientists were faced with two crucial uncertainties. First, is the signal really phosphine? Could it instead be another molecule masquerading as phosphine in the data? Second, if it is phosphine, where does it come from? Is it truly biological, or can it be explained by some unusual chemistry? To answer this, researchers didn't jump to conclusions. Instead, they reanalyzed and triple-checked the data, testing it with multiple methods. This wasn't a one-time measurement. They knew the claim was extraordinary, so the evidence needed to be extraordinary as well. And here's where we as curious explorers should pause and ask ourselves, if you were a scientist on that team, would you dare to suggest life on Venus knowing the scrutiny that would follow? To make the detection, two powerful instruments were used. One was the James Clerk Maxwell telescope in Hawaii, perched high on a sacred mountain. The other was ALMA, a giant array of radio telescopes in Chile. Both specialize in microwave observations, but Venus presents a challenge. It's too bright. Unlike distant faint galaxies where every photon is precious, Venus floods telescopes with so much light that it can overwhelm their senses. It's like staring straight into a spotlight while trying to see the dust floating in the beam. Other instruments have been brought into the effort too. The Infrared Telescope Facility in Hawaii and SOFIA, a unique telescope mounted on an aircraft, were both considered. But even with all this technology, adapting instruments designed for distant objects to study our dazzling neighbour is no easy task. So while we dream of using something like the James Webb Space Telescope in reality, it would probably be overwhelmed by Venus's glare. If only discovery were as simple as pointing a telescope and exclaiming, "There it is, phosphine." The truth is far more painstaking. The raw data was noisy, full of distortions. Scientists had to clean it, using sophisticated algorithms, always careful not to introduce false signals. They tested different methods, some designed specifically to look for phosphine, others pretending not to, just to check if the molecule would appear naturally in the analysis. It took years, nearly 3, from the first detection to publication. During that time, the team was constantly challenged by external reviewers. Are you sure? Have you considered every alternative? Each round forced them to redo their work with different techniques. This is science at its most honest, slow, rigorous, and sometimes frustrating. But it's the only way we can be confident in extraordinary claims. Here's a strange twist. Venus hardly has any hydrogen in its atmosphere. On Earth, hydrogen is everywhere, and life depends on it. Phosphine itself is a molecule of phosphorus bonded with hydrogen. Without hydrogen, it's extremely difficult to make. This makes the detection even more puzzling. If phosphine really is there, how is it forming? Some have imagined if there is life in Venus's clouds, it wouldn't resemble us at all. It wouldn't crave water or oxygen. It might thrive in sulfuric acid, treating it as comfortably as we treat oceans. To such organisms, we would be the strange ones, creatures allergic to acid. And this is where we must let our imagination stretch. If life is common in the universe, must it always look like Earth life? Or could Venus harbour something completely alien? What about non-biological explanations? Could volcanoes, lightning, or deep atmospheric chemistry be producing phosphine? In theory, yes, but only in vanishingly small amounts. Even if phosphine were created deep in Venus's atmosphere, it would likely be destroyed before reaching the heights where telescopes detected it. Models suggest that the conditions simply aren't right. There isn't enough hydrogen, nor enough of the high-energy processes required. So far, no natural explanation has convincingly matched the observed amount of phosphine. But let's be cautious, the atmosphere of Venus is still poorly understood. We may be missing an exotic process we haven't yet imagined. Phosphine isn't the only mystery in Venus's skies. Astronomers have also detected an unidentified substance that absorbs ultraviolet light. No one knows what it is. Could these two puzzles, phosphine and the UV absorber, be connected? Some have speculated that life once existed on Venus's surface. Billions of years ago, Venus may have been habitable with liquid water and mild conditions, but a runaway greenhouse effect transformed it into the furnace we see today. If life did exist, back to then, imagine the tragedy. Entire ecosystems forced upward, adapting desperately to shrinking habitable layers high in the clouds. If such life survived, it would now cling to existence in one of the harshest places imaginable. It's a sobering reminder planets can change, and not always for the better. Another idea is panspermia, the notion that life can spread from planet to planet, hitching rides on asteroids or comets. Could Venus and Earth have swapped life this way? It's possible, but unlikely. The conditions on Venus are so extreme that even Earth's toughest microbes, the so-called extremophiles, wouldn't last long. If spacecraft made of metal have melted in its atmosphere, how could delicate cells survive? So while panspermia makes for an exciting story, it doesn't solve the mystery of phosphine. Now let's step back. Suppose one day we confirm that phosphine really is a sign of life. What would that mean for us? For centuries, humanity has clung to the idea that we are special. Yet the Sun is an average star. Our solar system is unremarkable, and rocky planets like Earth are common throughout the galaxy. Why should life itself be the one exceptional thing? Perhaps the greater truth is that we are ordinary part of a wider cosmic family. And wouldn't you rather live in a universe filled with neighbours, even if strange and distant, than in a universe where we are forever alone? The story of phosphine on Venus isn't finished. Scientists are still analysing, still debating, still searching for answers. Whether it's a clue to alien life or to some exotic chemistry, one thing is certain: Venus has reminded us how little we know, even about the planets next door. As we look ahead, future observations may settle the debate or open even bigger questions. Until then, we'll keep watching, keep wondering, and keep asking, what if we are not as special as we thought? Thanks for joining us on this journey. As the world turns its eyes toward Venus, we'll be here to explore every discovery together. Let's see where the story takes us next. The mystery of phosphine on Venus is far from solved. Maybe the molecule is a trace of alien biology hidden in the clouds. Maybe it's the signature of a chemical process we've yet to understand. Either way, Venus has given us something precious wonder. We live in a universe full of unanswered questions. Each discovery, no matter how uncertain, pushes us to look deeper and to rethink our place among the stars. And that is the heart of exploration, not final answers, but the courage to ask bold questions. If you've enjoyed this journey, make sure to subscribe to Cosmic Compass for more stories about the strange, the beautiful, and the mysterious universe we share. Until next time, let's keep our eyes on the cosmos and our minds open to what it might reveal.